In this lecture, I'm going to talk about the I/O basics, dealing with input and output in C++. So so first of all, C++ supports the C-style I/O, like printf, scanf, and a bunch of other related functions. And that is C language. Well, of course, C++ still supports those. And then you are not encouraged to use them. Instead, you should be using the C++ I/O classes. So the I/O classes are mainly basically shown in this diagram. This is a class diagram that shows the inheritance relationships and the object that you're familiar with, for example, to the C out and C in, well, that would be the actually the object of the basic O stream and a basic I stream. And they are the primary classes that so far you have dealt with by printing characters to the standard output, the console, and then also can take input from the standard input. That would be the, let's say you're typing in something on the keyboard. But that's not all, right? So there are, different types of streams that you can actually process. For example, you may want to deal with the files. So, so you see there's this output file stream, and there's the corresponding input file stream as well. And then you may want to deal with strings in terms of a stream-based I/O. You can actually even use that. It's more like acting like a buffer. So that is the O stream for output and I stream for input. Okay, so the O string stream, I string stream, these are the output and input streams. And then the couple classes in the middle, these are actually the classes they inherit from both the input stream and output stream. So, in C++, there's a multiple inheritance. We're actually going to talk about that in the next lecture. And so these are the ones that the objects will have the both features for input and output, if that's what you need. Okay. So first of all, let's look at O stream and I stream. What is the idea behind them? So what a stream really is this is O stream for output, and essentially you've got typed values. Those are objects. You got characters, numbers, and some form of an object as represented here. But again, so whatever object you may have, and then you basically using this O stream to put the essentially characters into a stream buffer. And then that will be essentially sent to some place as a byte sequence, okay? And that process would be reversed. In the case of iStream, you get a byte sequence from somewhere, and then that gets put into a stream buffer. And that, and then through this class, it will, you can extract values out of that stream, maybe a character, a number, or some kind of object. So the standard library, of course, supports all this built-in types, fundamental types, the strings. And so many of the operations you can do with O stream, I stream on those types because they are supported by the standard. And then you can also, of course, define your own stream behaviors for your own types. Now, let's take a look at some example for the O stream. So from in the very first hello world, probably you've seen this. You can use this stream insertion operator. And here we're outputting a number here, an integer, 10. It's very basic. Now, we know this is an operator, and this a binary operator takes a left-hand side and right-hand side operands. And then here's another example. And we may output some string. This is a C-style string. And then we continue, we chain that operation again. This operator is getting chained by outputting multiple things. Now, the reason we can do that, of course, because we already know this operator that's overloaded that will basically return the O stream again. And that's why you can continue to use the operator with another operand, right? And so this is the associativity rule for this operator is left to right. So that's basically evaluating from left to right. So if you invoke this function with a 10, this is going to output the value of I is 10, right? There's a typo here, but anyway. So how do you do the input? The input is a little more complicated, in the sense that typically you want to, verify your input. The validate, is that what you want? Now the default behavior is maybe sufficient for most of the use cases. So let's take a look at this simple example here. Let's say we want to get a int and a double from the standard input. So then you define those variables, and then you basically extract the values into those variables. And so this is the stream extraction operator versus the one we saw before to output. That was for insertion. And so it's just a different direction if you look at the greater than signs. And then your input, maybe you put in a number, and then put some white spaces in between, and you have another number that's a scientific notation here, and that will be recognized read as a double as well. So that's really just a basic usage of iStream. And then here's another example. So we probably want to print out some prompt telling you, okay, we are trying to get something, and hey, please enter your name. And so we declare, we define a variable string, str. And so then we, now we're going to take a string into this variable. Now, the default behavior here is it will be terminated with the white spaces. Well, the initial white spaces will be ignored. But once you put in, type in some characters, and then you have a space, for example, and then the rest of it will not be read. It will only take the first word, essentially. So this may or may not be what you want. What are you going to do if you want to, input multiple words? So then you use getLine. So this getLine function defined in the string library that allows you to read a line of characters that may include white spaces in the middle, inside. And then the way you terminate, of course, this reason it's called a line, is you enter a new line, then it will read everything up to that new line. That becomes the value of your string put into this variable here, okay? And the IO classes, they maintain a state. The state may indicate there was an error, or it was end of a file. So now let's look at some kind of example here. Let's say we want to read many ints. We want to read many ints, put them into a vector. In fact, this is kind of unlimited if you want to, obtain sort of a sequence of those ints. And so we have a for loop here, and we essentially just loop through and get the and read the value from the input stream, I stream. The I stream, as see here, we're actually and then we're gonna actually use the extraction, right? We want to obtain the value, put that into I, and then we know this returns the IS itself, right? So that's kind of how this operator is overloaded. And the IS, okay, now here we know this takes a condition. It's a condition here in this for loop, that in this syntax, this regular for loop here. So it's a condition, so it means this could be, the compiler needs to somehow convert this to a Boolean, right? It's not a Boolean object we know, it's iStream. How is it able to convert this to a Boolean? So let's actually take a look at this, right? Just just to understand how this is done. So let's say go to cppreferences.com, and I want to look at iStream, and this is the class I want to look at. And then when you click on this, it goes to, as you see, basic iStream. Why? Because the iStream was essentially as alias of basic iStream of char, as you see here. Okay, so that's why the functionality is absolutely the same as a basic iStream, except this is instantiated with the type char, and then this is a template class. We're going to explain template class very soon, and you already know function template, so this is class templates are not that much different in terms of how you declare a template header. And so we came here to look for essentially the reason we can use this, like in a condition. So I'm going to search for, is there a operator bool, right? That's just my guess. So yeah, there is operator bool. Let's take a look. Now we know the operator bool, this is for type conversion, right? If you recall the type conversion. So this allows the consumer of this class to convert an object of basic iOS, as we see the class hierarchy, and then this, both iStream, OStream, they all have this same, they inherit this same function, this member function is inherited. So they all can be converted to a bool. Now, what does this, bool mean? This second form, it returns true if the stream has no errors and is ready for IO operations, right? So no errors is all good. Now, this is really it's not what is happening, right? In that for loop. So the way you use it here, this is we're using this, it needs to be converted to a Boolean, right? Be treated as a Boolean. And this actually will not be really using this because we're not doing a explicit casting. This keyword here means compiler will not be doing the implicit conversion. And so this is not what we're using here. If we added, let's say, static cast angle bracket with a Boolean inside, and then that will, it will do, right? It will use that, but this is not what's happening. So in fact, it's using the first form. So the first form, it returns a null pointer if fail, return true. Okay, this fail is another function defined that actually just means there's errors. Something happens. There's a failure. And so in the case that fails, so as a condition, then if something stopped the stream processing, it's like it got a, let's say you're putting a character that's no longer an integer, right? And it will stop. Well, how does it stop? Because in that case, it failed. And then because of this operator, this can be used to convert implicitly, right? So this would basically be and this was 11. So actually, you know what? This one will not be. I'm not sure if this documentation is correct. So anyway, so actually, if we see here, this says until C++ 11. So this means this form is no longer there. It is no longer there. And so actually, and then if this is explicit, and then so I think, let's actually take a look at. This operator makes it possible to use streams and functions that return reference to a stream as a loop conditions. So loop condition resulting in idiomatic C++ input loops. And so this is fine. For example, you put this stream extraction essentially returns the stream itself, and then put that as a condition. And it says this is okay. So, well, it looks like is still somehow used, even though this is an explicit operator function, explicit conversion. So I need to kind of check into this a little bit later. So this is kind of a little surprising. Actually, I did not pay attention to this until I see this. This is actually an older, the older version. This is no longer, basically no longer in the standard C++ 20, if that's what we're, what you're using. Okay, so let's move on. So anyway, we're reading a series of integers, right? And so that's kind of just the basic thing. Now, here's the thing: when you actually do this, you basically you can separate the integers with the white spaces, and then when you enter new line, and then that's when, well, it will not stop. By the way, in new line will not stop. It's still one of the white spaces will be ignored, and then only way for this stop is to basically enter something that's not an integer, like just, letter A, for example, that will stop it. But when that actually stops, the fail bit on the stream, the state will be set as failed because it has encountered something that's not intended to be read. So that's the thing. Now, what if you want to, you don't want this to fail. You want to have some kind of a way of terminating the input. And so this is one way to do it. So let's say we're actually going to take a terminator string, that whatever you specify as the way to terminate that input of sequence of integers that you're trying to take from standard input. And so we're still going to read them, right? We're going to read this thing until it encounters something that's not integer, and then it will stop, right? So, so first of all, if it because it's a end of a file, now end of a file, maybe not for the standard input. Let's say you're actually, as we know, because the inheritance hierarchy, let's say it's actually a file underneath, may not be your standard input. Let's say you're actually having a file, the end of file is reached, and that is fine, and then you return. In that case, it's not really a failed. It's basically end of file condition. That's another state that will be remembered that you can check. And then if it's actually not end of file, it's actually failed because encounter something that cannot be converted to that type. And then first we'll clear that state, and then we return that character back to the stream because we want to match to see, are we actually encountering this beginning of a terminator, right? So we're going to see if we actually will be able to read the terminator. So we're going to make a string and read that from the stream, and then see if that equal to the terminator. If that is the case, and now we return the vector, and then also know that the fail bit has been cleared. So this is a success case. Otherwise, if we did not see a terminator as something else that stopped it, then it's still going to be a fail situation. So we're going to set the state back to the fail again. So this is the flag to set on the stream. So that's basically, a way to handle the state of the stream, if that is relevant to when you're processing the stream. So of course you can, perform I/O on a user-defined types. Now, previously I kind of mentioned to say, well, most of the time you're going to be using classes. If you're doing OOP, pretty much that's what you would use for the most of the time. Now here for demonstration purposes, and then you see in the simple examples that people are going to use structures, because again, structures are the idiomatic way using structures, you kind of, those members are going to be public. So you guys just simply declare some members here. These are the member variables. There's really no member functions here. And then this by default, the member variables are public for a structure. And this is obviously not very the best way to hide information, right? The OOP principles. So this is mostly kind of for in this case with for demonstration purposes. So and so this is a structure and there's an object, and then here we actually overloading the insertion operator, and you have seen this many times. It's a very simple. Okay, here, so to access the member variables, just like a class object, it's the same thing. You have this entry and the E dot, the members, and so we're outputting in this format with the curly braces and separating the variables with a comma, right? So it's a simple insertion. Now, extraction is a little bit more involved. Let's say you want to take the object in the form of this curly braces with quoted name and then comma and number in this format from the standard input. And so you can make an object of entry out of this, right? And so then we're going to need to process that a character sequence. So let's declare characters C and C2, and we're going to use them to hold temporarily the characters to examine. So first of all, we're going to read a single character to C, and then we're going to examine. Okay, this C we just read, is that a curly braces, right? So by the way, when you read with iStream, the beginning, the very beginning, the white spaces will be ignored. Okay. So that is fine. So we're looking at in the very first character, there's not a white space, and then we're going to see if this is a curly braces, the beginning, the starting curly braces, and then if that's the case, and then we're going to check another character spaces. You see the white spaces are going to be ignored, right? We're going to read another character, see if this is a double quote, right? Just by looking at this format here. And this is the case we're dealing with. If it's not following this format, that means, okay, it's not valid entry, right? If it's not getting what we are, so this is, okay, so last line is kind of a hidden. So actually, yeah, never mind. The last line is setting the fail bit because that failed, right? So we're going to look at the situation where, let's say here we got the valid input. So following this format here, so now we read up to this point, we'll have encountered quote and the starting of this name. So then we're going to make we're going to read a string, and this string, let's see. And how do we read this string? So the way we can do this here is now we want to make sure we're going to capture everything inside, including white spaces. So then we're going to switch to this get function here on the iStream instead of using the extraction, because the extraction is going to ignore white spaces. So this will not ignore white spaces. It will read every character. So we're using a while loop here. We're reading this thing character by character, and until we encounter the ending quote, right? So before we encounter ending quote, we're going to concatenate every character into this string name. So we're going to read the whole thing, including spaces in between. And then, well, then we got the name. we encounter the ending quote, and the next character to look at is the comma, right? So we're going to read another character, ignoring white spaces, and get a comma, right? And then we're going to prepare to read the number. And so here we have, and then we're going to read a number, and also we're going to read, the closing curly braces. We're going to read as another character, and then if this is ending curly braces, closing curly braces, then we're gonna actually, then means we got the number, and then there's the end of the pair. Okay. And then in this case, now we're gonna make this object entry. And here you see this initializer, again, the brace initializer with these two, the member variables. Okay. So yeah, in the order of declaration, by the way, you got a name and a number. And then so we're making up this object and return, and this object is set. Now here you see this is obviously because we need to return a reference to the iStream. So the way to return back the, here we're going to have using an output parameter here to output this E, the entry object we're trying to extract it into. Okay, so this is a reference. So we set this reference and then return the original iStream. Okay, so that's basically what you may typically do if you want to read a particular format for your custom defined object. Oh, formatting, and I think many of you are familiar with formatting and using the stream manipulators. The manipulators, there are many of them, so you can look up in the reference. These manipulators defined in these headers: iOS, iStream, OStream, and IO manipulation, basically IO manip. This is for manipulators. And by the way, this header mostly contains the manipulators that take arguments, but the other ones, well, the ones typically don't take arguments. So you see, for example, here we're printing a number, that's the default behavior, and then we're going to say we want to print out from this point on, we're going to print out the number in a hex hexadecimal format, and then we're going to switch to octadecimal format for another number, and so the output could be looking like this. And this is just an example. These are the manipulators. Now, what is a manipulator? This is actually this basically could be implemented. Now, it is implementation defined. The standard doesn't say how it is implemented, so it could be as an object. This could be some kind of object, a simple object that as an example, it could be implemented as a function object, for example, right? And this object, when you invoke it on a stream object, and then it will actually set the particular flag, right, for that stream, and then then it will switch to certain kind of formatting. There's a lot of formatting flags for stream. And these things, now here, let's take another example for the printing double double numbers. So these scientific format, the hexadecimal format for float, and then there's fixed format, and then there's default, which is the general format. These are the things actually corresponding to, you see every single one of them is available in that string formatting function, the standard format function, right? The format specifier, which is the intuitive way of printing formatting a string with the placeholders in a string, right? And so the meaning of these things, you basically, when you need to use them, you have to basically just look up. If you don't remember, obviously, who's going to remember all of this? There's a lot of them, by the way. And so you can just use this cppreference.com as an example. You can search up, for example, scientific, right? So let's say scientific. Let's take a look at that manipulator. So there's, okay, so here is documenting all of this for, and actually we just use this in the example here. And as an example, for example, the first form and the fixed manipulator, and that when you say it sets the float, it sets the float field of the stream to fixed, as if by calling the stream set flag, right? So everything, it comes down to those flags. Those are the flags that are defined in the iOS base class. All right, so it's all this IO streams are inheriting. It's all available. Okay. So the file streams, right, we don't necessarily have to just deal with the standard input and output. The standard input and output, by the way, they are also basically like file streams, but there are special devices though. You know, the standard input, standard output. There are, for example, Unix systems, they are considered files in terms of how the system interacts with them, but they're of course not really a file that has a particular size. There's a special device, special file. And then there's regular files or directories and symbolic links. There's those files. They can be, then you can access the specific functionality that's specific to files, including sockets for network I/O. That will be basically things you can, you can deal with them here. And there's the classes that use the IF stream to read from a file, OF stream to write to a file, F stream, they can do both, right? This inheriting from the both classes. So here's a simple example. You may, here's a target file, some kind of, destination target. That's the file you want to write to. And so you can, you open this file, then you deal with that as just like your O stream. Okay. All those things that we just explained will work the same way on this OF stream. And for reading, you use this IF stream and reading from a source file. This some kind of path to a file, for example, and then you check if this file was successfully opened, and then you go and then you deal with it. You can read from that file, just like how you deal with what we just shown from a standard input like cin. And then you can also deal with string stream instead of just dealing with a string class that is designed to hold on to, let's say, typically some kind of a string constant. All right, if you're dealing with a large amount of a string or a character, a huge string, and then or somehow it's coming from some place in a fashion that's more of a streaming fashion, then you may want to deal with, again, even for internal, for holding on to just a certain amount of string, just in memory temporarily, like a buffer. And this is something you can do to manipulate strings. And so you can deal with I string stream is for reading a string, reading from a string, an O string stream to write to a string. And then string stream is inheriting from both. And this is allowing you to use the stream-based IO facilities, all the things that we explained so far, to deal with a string. And, this is the one way to do it, right? And then you also know that the standard format function, the format library, that also allow you to do to manipulate a string. So that's another alternative. So this is kind of just what has been there for a long time. This is the string streams. And an example of using string stream. Here is a function template. You have a target type and source type. By default, let's say they're going to be string. And Then we're actually going to use a string stream, we call it interpreter. And then we're going to basically read the source into the string stream. And so this allows you to essentially, now this, of course, this argument, if you have your custom defined type, and then you have to support the, overload the operator for stream insertion, right, for this to work, okay? If it's a built-in type, of course, that's already there. So we insert this argument into the interpreter, essentially turning that into a string. If that is successful, if that's not successful, right? And then we're gonna basically throw an error. Now we're gonna explain exception handling a little bit later. This is saying if there's a problem, we're gonna throw an error, and the execution the function execution will stop, and then there will be an exception throwing out of this function. So we're going to explain a bit more about this if you're not familiar with this. So that for the time being, just know this is error condition. Your execution of this function execution will stop here. So we basically do the conversion. Of course, this is one thing we're going to do. So suppose it's successful. And then we're going to essentially return. Then okay, so basically we say if this is the argument, we're going to turn that into a string. If that's not successful, we're going to basically, then we're going to print out that into the result. Okay, so if that's not successful, if that is a false, means that this is successful. So I see the condition is a little convoluted here. If this is successful, we actually inserted arg to interpreter. If this is successful, we're going to continue to run this line, right? This binary expression. And then this line will say we're actually going to now extract. We're going to insert this into the interpreter, and then we're going to actually extract this out into the result, which is the target type, the target object, okay? So we'll put in the string into this target. Now your target type, if it supports, if it's a custom object, right? Custom type, like some kind of class or structure, then you just overload that extraction operator. So remember that example, we had a pair like for entry, name and a number. So similar, right? So at this point, this is the string, and then this now is converted into the result object. Okay, if this is successful, then we're going to continue, and then what this means is we're going to ignore white spaces. This WS is another manipulator. We're going to ignore white spaces, and so we're going to basically read the whole thing to the very end, and then checking if it is actually the end of a file to the very end of the input. And so that's what we're expecting. If it's not that, and then we'll fail, right? So all these cases, even though, as you see, it's kind of, we're combining all these error conditions into one single condition, and then we're going to throw an error. Otherwise, this is what we're actually intending to do, these three statements, three expressions here. So then we'll end up with a result. So we actually convert it from a source object to a target object of a different type. And then in the middle, we're using this string stream as the sort of the intermediary. And then, we're converting from the source object to a string, and then from that string, converting that to the target by using this string stream mechanism. And it's because the string stream supports both the insertion and extraction, right? So I both IO are accepted. So for example, you may invoke this to function with a 1.2, which is a double. And then by default, it will be converted to a string because those are the default parameter. The template parameter types are going to be the default are strings. So yeah, that's a little useful function here. See the usage of a string stream. Then there's this file system library. Now we can use a file system to express the path. We know different systems have different ways of expressing path, and this is a standard way of dealing with platform differences. And then you can navigate them through this library in a portable way. And then also you can examine the file types and permissions. So here's maybe a simple example. So the file system classes or entities are defined in this namespace std : file system. And that's kind of too long to type. So we're going to make a namespace alias called fs. So, so here we make a path object. Now, by the way, this is the assignment form of initialization. So you can use the curly braces, the initializer. That's actually preferred. So you can, should do that. So then we'll have a assertion statement. This is the assertion macro, by the way. And this is the kind of the, supposedly has some, this is a board carried over from C. And we're essentially asserting that this file exists. This is just an example. You may not really do this in your actual program. You may handle this in a more graceful way, for example. So this is an example to check if this file is actually a regular file rather than a socket or a, let's say maybe it's a character, some kind of block device, right? Some, standard input output that would be special files as an example. Or could it be, a symbolic link or a directory? Those are different types of files. And so this is the regular file type. And then you can check the size of the file with the file size function. And here's a little bit more involved example here we're actually looping through a whole directory. So dealing with if this is path is a directory, and then we're gonna have a range-based for loop here actually, but this is using this directory iterator object initialized with P, which is the path, and it will iterating through this iterator object. Each time we'll get a directory entry of X. And then we're gonna make a path out of X. So that we're actually accessing the path portion of that directory entry, which may hold on, a bunch of information that we do not really care here. So we're only looking at the path of X. And then we examine the extension, if extension is .exe, and then we know it's a Windows executable, so we just print that out and print the stem, which is the part before the extension. Or otherwise, we're going to check something else. We're going to see, so first of all, turn that extension into a string, and then see if this is equal to cpp c dot cxx. I think this is a missing dot. And then if that is the case, it seems to be a C++ source file. Just some simple example here, right? So that's what I have to share about this basic I/O. There's certainly more to it, but this should be a good introduction to it. And then in some of our exercises or some of the homework, you may be asked to use some of the basic file I/O or standard I/O. We have the console or standard input and output that you've been doing most of the time, but perhaps at some point maybe you deal with a file. So at least familiarize yourself with a little bit of file operations, and then when you want to look up the operation here, for example, this is directory. Okay, I want to look up in more details here. Just look up is directory in this Just want to show you, if you want to see, okay, then here's just in the namespace of file system. This is the one we're looking for. And then this will show you, the signatures of different forms overloaded function. Most of the functions are in the standard library are overloaded. It's not just one form. There's like multiple. And you can see what is the meaning of this thing, what it can do, the parameters and the return value. And then there's even example. Some examples are very even quite a bit involved. That just helps you to study those things. So that's really what I wanted to show you guys. Okay, thank you.